So in association, generally you measure association seeing the nature of variable. If the nature of variable is a categorical, and I think by this time, now you know what is a categorical variable and what is a scale variable. So both nominal and ordinal variable are together known as categorical variable, and interval and ratio variable are known as the when the level of measurement is interval and ratio, then it is known as the scale variable. So association, depending on the nature of the variable, you measure the association. So what do we mean by association? Association means like any relationship between the two variables. And this term is a statistical term. It is an English term also, this association. But in biostatistics and epidemiology also, we define this term association as relationship between two variable or more than two variable also. So chi-square test. So today we'll see the association between the categorical variable. Categorical variable means nominal and ordinal variable. So if the nature of the two variable is categorical in nature, then you perform the chi-square test of association. And we'll see what is this chi-square test of association. So we'll start this session with some basic concepts. What are the various research questions for which we need this chi-square test of association? And from now onwards, since we are starting with inferential statistics, if you can recall yesterday's session, yesterday we only talked about the descriptive statistics. So what was the descriptive statistics? So descriptive statistics is it is basically the summarization of data. And the summarization is like, how do you summarize your data? So depending on the nature of variable. So if the nature of variable is categorical, you summarize your data in the form of counts and percentage. If it is continuous in nature or scale variable, you summarize your data seeing the normality, and after that you see the skewness of data. You measure the mean, median, that is the measure of central tendency. You describe the data in the form of a dispersion like range, standard deviation, standard error, and again you may describe your data in the form of if there are any outliers or if there are any missing data, and again you also describe in terms of position. So these are some basics of the descriptive statistics. But in descriptive statistics, we don't perform hypothesis. That means hypothesis testing is not done in the descriptive statistics. That's why from now onwards, from today onwards, we are starting with inferential statistics. That means whatever statistics we'll perform, we will always have a generalizability. That means we will estimate the population parameter also from our sample statistics. And for that, to perform inferential statistics, there are some assumptions and there is some hypothesis. So hypothesis, we'll be seeing the null hypothesis and alternate hypothesis. And then we'll see what are the commands in the JAMOVI through which you can perform these associations and how to interpret those like output, and then we'll summarize the session at the end. So starting with these basic concepts. So like if I ask this question, like we said in the beginning, that association is relationship between the variable. The nature of variable can be a categorical variable. It can be a continuous variable. So now let's see, these are the two variable. And the research question, diabetes status, gender has got two levels, male and female, and diabetes status has got like diabetes present or absent. Then what is the nature of these two variable? Yes, all of you please type in the chat box. The nature of these variables. Categorical. Right. So both these variables are categorical in nature. For example, this is another example. A study was conducted, and this is like more of epidemiology. Means like in this example, I am talking about how that study was conducted. So a study was conducted where I have selected few subjects and I asked two questions. what is the gender of the subject, and are you diabetic or not. Because from now onwards, especially in these chi-square statistics, if you see how you have selected the sample, that is also important. And the choice of chi-square test again depends on the this methodology also. That's why you should like in the background, whenever you perform your analysis, you have to keep in mind your methodology also. So in this case, like if I ask this question, what is your gender, from the same person. So in this picture, like you can see, it is a group of people, and from in this I have selected this sample from the total population, and I asked two questions. What is your gender, and are you diabetic or not? And then I have made a contingency table. So what is a contingency table? So contingency table is also known as a 2 by 2 table, or a cross tab or cross tabulation. And it is an arrangement in which we like classify the variable, and we classify and put the data according to two categorical variable. So there are different types of contingency table. So this is a 2 by 2 contingency table where there are two levels of each category. And in this case, by this diabetes, because categorical variable, again, it depends on the number of categories. So if there are two levels, you call it as a binary variable. So both these are binary variable. So in this case, it is a contingency table, which is a 2 by 2. So what will be the total number of cells? So what is a cell? So basically a cell is this one. This is one cell, this is another cell, this is again one cell, and this is another cell. So if I ask in 2 by 2 table the total number of cells, what will be your answer? Okay, Radha, right, it will be 4. Now this is a 3 by 2 contingency table, and the two variables are, the one variable is the BMI category. The BMI category has got 3 levels: normal, overweight, and obese. And diabetes has got no and yes. This is a 3 by 2 contingency table. So all of you please type in the chat box what will be the number of cells, total number of cells in a 3 by 2 table. 6. Very good. Why the total number of cells are important to know? Because we will see in the assumption that in chi-square, before performing chi-square test, you need to have satisfy few assumptions. If your data meet those assumptions, then only you can perform a chi-square test. That's why total number of cells in any contingency table you should be able to like tell. And I think in the previous workshops, we have experienced that many times there's a problem. Let's say it is a 5 by 5 contingency table. Then what will be the total number of cells? Yes. If it is a 5 by 5 table, yes, Subhapriya, right? It will be 25. Dr. Manju, no, in 5 by 5, Dr. Manju, it will be like total will be your 25. 10 will be there in 5 by 2. If there are 5 levels and one variable has got 5 level and the other has got 2, then only yes, you are right. So these are like the total number of cells. Now, if if you see that these are the 3 tables, maybe from that sample which we have selected, we have measured the the status of diabetes as yes and no, and gender as male and female, and I have made these three tables. So looking at these tables, even if I am not performing any statistical test, can you tell on the basis of the numbers which has been distributed, like in which table there is no association, in which table there is some association, and in which table there is a strong association? So these are 3 tables. This is table number 1, this is number 2, and this is number 3. So table 3 is what? Can I see the chat? Strong association. Okay, table 3. Okay. And in table 1, what is there in table 1? Okay. So no association. So yes, even if you don't perform any statistical test, just by seeing the number and the distribution of the people in the two category, you can say that yes, there is no association in table 1. There is like some association in table 2, and there is a strong association in table 3. Rightly pointed out by all of you. So well, that is, if you see the male, the total number of diabetic are out of, if you see the number, out of 80 there are 60 male, and in female out of 50 there are 10. So definitely it is more in male. So so this is how you perform the, so first you 3 times. Okay, I don't know. Am I audible to all of you? Like, is the voice cracking in between?
Yes, yes, clear, ma'am.
Okay.
No, ma'am, no crack.
Okay, thank you. Thank you. So, what are the research questions for which we need this chi-square test of association? So, like again, I said it is the association between the two categorical variable. So, if like one categorical variable is the BMI category, where I have defined the category as normal, overweight, and obese, and another is the history of cardiovascular disease, yes and no, then you can perform a chi-square test of association. Surgery by two methods, surgical technique X and surgical technique Y, and you are seeing the occurrence of surgical site infection. Square test. Or if you want to see the association between the quality of sleep, where quality of sleep, I have got two categories, a good quality of sleep versus poor quality of sleep, and academic performance, good versus poor. So both categorical variable of medical undergraduate, then also I can perform this chi-square test of association. So in all these example, what we have seen, that there is a trying to look the association between these two categorical variable, and the appropriate statistical choice in such case is the chi-square test of association, which is also known as the chi-square test of independence. It's like opposite to each other. If there is a association, the variables are not independent. If there is no association, then the variables are independent. That's why this is also known as either the chi-square test of association or chi-square test of independence. But again, this association doesn't mean that it is causal. That means in the previous table, you have just seen that the diabetes was more common in male. That doesn't mean that the male gender is a causality for occurrence of the diabetes. So this chi-square test only tells us about the association between the two variables. And you know about the causality, there are other criteria. There is a Hill criteria of causality in which there are 7 to 8 conditions which needs to be fulfilled before we call a variable to be causally associated with the another variable. So, like I said, from now onwards, I'll be talking of the inferential statistics. So all these chi-square and all these are inferential statistics. That means you perform a statistics, you calculate the statistical value on your sample, and then you also project about the test. Like mostly you will see it is a very common type of test which is performed by everyone. Everyone means especially I'm talking about the students here, whether it is the MD students or even the UG students. So it is like we start, it's the foundation beginning. But again, you will see that many people they miss on this chi-square because it is, I mean, it is considered to be a very easy test to perform and interpret. But if you don't like see the assumptions which needs to be fulfilled, there are chances that you are likely to conclude something wrong. So like the first assumption that we know that there should be two categorical variable, and there can be any levels of these two categorical variable. That means that categorical variable may be a binary variable or may be a polytomous variable. What do I mean by polytomous variable? That the like BMI, it is not having only two category, like it is having more than two category. So Or yesterday, like we divided that, BMI into the 4 or 5 category. So when a variable has got more than 2 levels, then it is known as the polytomous variable. So chi-square test, the essential criteria is it should be a categorical variable. If the variable is continuous, and if you wish to perform chi-square test, you need to convert that continuous variable into the categorical using the transform option, which we have seen yesterday. And the second assumption is like they should have more than two category or more than two category of each variable. The third assumption is the independence of observation. Now, what is this independence of observation? Independence of observation means it is a methodological issue. When you recruit people from sample, you should be recruiting one individual only once. You cannot include one individual more than once. So it can be an error. Like, uh, you know, if you are like, if the research question is like you want to understand or you want to know the prevalence of depression in antenatal women or in postnatal women also, and you are recruiting people, you are sitting in a clinic, and or maybe you are sitting at a facility and you are recruiting all the pregnant women or the postnatal women for this prevalence of depression, maybe the antenatal depression. So, like if the women comes to you on, let's say my eligibility criteria is 12 weeks to 32 weeks. So if a woman comes in 16 weeks, I recruit that woman again because antenatal visits women come comes for more than one time. She may come for like 3 to 4 visits. So if she came again, if she comes in second visit, I again recruit that woman because I this question was not there in my questionnaire. Like, have you visited before this, or have I included you, or have you responded to this questionnaire before? So in that case, what happens? Like I respond to this. I took that woman twice. So that means the two observation. And what do I mean by observation? Each row. Remember, yesterday we talked about row and column. A column is for one variable, and each row in an Excel sheet. Why I am talking more often by row? By that you can visualize your data. So in each row of that data set should be unique. There should not be two rows which are similar to each other. Okay. That's why, if what is independence of observation? The rows in a data set, it should be independent of each other. It should not be related to each other. Related, how they can be related? They can be a same people, the same person considered twice when you are surveying, or they can be related as like let's say spouse. Spouse means there's let's say the same study diabetes. If I am doing that study and I like male, and if there are male and female, I want both gender to be represented in my sample. And if I recruit 50 couple, I can do that. I can go to 50 household and I can recruit 50 couple. So I will have 50 male and 50 female. But again, is are these observations independent? So answer will be, what is your stake on this? Are these, if I do such like in methodology, if I take 50 couple and then I consider 50 women and 50 men as separate gender, is this assumption of independence of observation, is it does it hold true or not? No. Yes. Can you show me the channel? Selection bias. Selection bias can be there, but again, I am talking about independence of observation. So you are saying no, but what is the reason? They are two different people, and it is convenient for me. I don't have to go to 100 houses. But in this case, same individual is not entered. In one row, you have got husband, and in another row, you have got wife. Then what is the problem? Here, though, same individual is not entering. Why this? If I say that this independence of observation, it is not like this assumption doesn't met true, then because Like there are many, although they are not related genetically, but there are many factors and many background characteristics which are same for spouse. Like diabetes may be the environmental factor, dietary, lifestyle, sleeping, all exercise habit. So they are very much related to each other. So that's why the independence of observation, this assumption will not be true. I mean, this assumption doesn't meet. Or if I take twin pair, like twins, there can be like male and female twins. If I take like 50 twin pair, where and then I just consider them as a separate people like male and female, then also this doesn't true. But that doesn't hold true. Why? Because then again, twins are also related to each other. So what do I mean by this independence of observation? That each row in a data set should be unique, should not be related to any other row. That means they can it how it is possible? It can be possible if you recruit one individual twice. Then this doesn't holds true. Second, if you recruit like spouse in your data set, male and female, and consider them separately because they are somehow related to each other. And third is your if you include twin pair, then also this assumption doesn't met. Okay, so this is how you should be in methodology. Whenever you explain these things, you should have like in methodology that this independence of observation is met. And then the next assumption is it should have a relatively large sample size. Large means adequate sample size. We will see this assumption more, this large sample size. Why I'm saying that it should have a large sample size. So now again, this in this slide only I have talked like independence of observation. What do I mean by independence of observation? That means there is no relationship between the subject in each group. That means the no it should not have even the variables. It should not be a pre or post test observation. Means category. You can have a binomial category when you have got a pre post observation. So pre post observations are again related to each other. So that's why they should not be paired. And why I am saying the relatively large sample size? Because in case of a large sample size, this one of the assumption of chi-square test is like at least 80% of the cell should have at least 5 expected frequency. We will talk about the expected frequency. What is the expected frequency? But this is one assumption that the 80% of the cell should have at least 5 expected frequency and none of the cells should have 0. That means all cells should have at least 1 expected frequency. The number. We'll see these assumption, but this because if there is a relatively large sample size, then at least in each cell you have expected frequency 1 and the in more than 80% of the cell, the expected frequency should be more than 5. Now, what is this expected frequency? So, have you understood this concept of independence of observation? Then I'll go to this expected versus observed count. Yes, Dr. Geeta, you are right. Same individual entered twice, but uh, like related to some other like spouse and twin pair also. They are also related to each other. So that is also like when you recruit people like this, then also this assumption doesn't, I mean, it does, you cannot say that this assumption was met. Okay. Apart from Dr. Geeta, any other, everybody understood this? The concept of independence of observation? Yes or no? Can I see the chat or they are not writing? Okay. Yes. Okay. Thank you. So now coming to expected versus observed count. So we always talk in assumption regarding the expected count. So if you see the expected count, what is the expected count? So observed count is like what you see in a 2 by 2 table. But what is the expected count that we'll understand? So let's begin with one variable. And in this case, suppose in our data set, we asked you regarding do you have hypertension or not. So regarding the prevalence or proportion of hypertension in our data set, and we have to see like, is it significantly different from national prevalence or not? So suppose, according to National Family Health Survey, the prevalence of hypertension in India is 22.6%. Okay, that's the NFHS data. And our sample size is total 170. So if I have to calculate, if I don't do any study, okay, if I don't ask this question from you people, like whether you are hypertensive or not, and I just apply the NFHS data into this data set, like 22.6%. So let's say it is 25%. Now calculate, or 22.6%. Now calculate the total number of expected hypertensive in the data set. Yes, all of you please calculate. The total sample size in our data set is 170. And the prevalence of hypertension in India, according to NFHS, is 22.6. So even if I don't ask this question from all of you, whether you are hypertensive or not, and I apply the same data, what is the total number of expected hypertensives in the data set? So Dr. Suresh is saying 38. Okay. Anybody else? So that we can see whether you can take a minute. Okay. Dr. Subhapriya is saying 38.5. Okay. So 43. How come these, I think if two values are coming, then I'll have to see. So I have to multiply this 38. It is 38 only, but I'll just show how come this 43 is coming. So 170 multiplied by 0.22, 0.226. So it is 38.42. Okay, Dr. Kirti, you calculated at 25%. That's okay. So the expected count will be your 38 or 38.5, but I am taking just the whole now. I'm in the rounding off, and I'm taking 38. And what is observed? So observed 31 number, I have seen like 31 people out of 170, they said that they are having hypertension. So observed is 18. It is like 31, so it is 18%. So there is a difference of 7. So now, in this case, what is expected? So expected was 38, but observed count was 31. Okay. So difference of this expected and observed is known as the residual. We'll see that in the 2 by 2 table. But this, if you remember, those of you who have studied some time, like any time during their study period, we always calculate the chi-square value by like observed minus expected, and then you square it. That's the statistically we calculate it, and in denominator we have got observed. But I'm not asking you to calculate using that formula, because here in statistics and using the software, it is not expected out of you that you will calculate using that formula, but you should know what is happening in the background. That's why we are telling you all these detailed. Otherwise, these all, you get these values automatically in the software. So now, if I ask this question, so that is the meaning of observed and expected. Okay, expected is like if you don't ask individually, and if you apply some other data, that is expected. And observed is what, when you collect your data, what actually you have seen, that is the observed one. So now let's again move to that question of association between the gender and hypertension status. So now if I just make this 2 by 2 table, and this 2 by 2 table is out of that 170 people whom I have interviewed or whom I have collected for the data, about the data. So let's say this overall result, if I don't apply any this thing, and if I calculate this, so 18% is my hypertensive status and 82% are non-hypertensive. So the null hypothesis assumes that there is no relationship between the hypertension status and gender in the population. That's how we form the null hypothesis. Initially, we start that there is no association. And the alternate hypothesis is like we say that there is association between these two. So if there is no association, so you can say that the proportion of this gender across these these two group, hypertensive versus non-hypertensive, though they will be same as per the null hypothesis. So because null hypothesis, so overall result, you see this 18% is the same 31. And then if you see, so if you see the total number, this is 107 is the total number of male and 63 is the total number of female. So if you calculate the expected number, so 82% of 107, now we have to calculate the based on this, because the 82% of this 107, 18% of 107, again 82% of 63 and 18% of 63. This is your expected count based on the null hypothesis. Okay, the same proportion, that's the expected count. And then now when I looked at the data set, this is my observed count. So expected count is what you like take assume that irrespective of gender, it will be the same in both, yes and no. And then this is the observed count, what you actually observe. So this is like you can say this is your difference between like observed and expected, and that is happening in the background of calculation, which says that yes, there is a difference between observed and expected. So this is the count, this 88, 19, 52 and 11. If you see these two count, this 88 is the expected, while this 80 is the observed. Again, this 52 is expected, this 59 is observed. Again, this 19 is expected, this 27 is observed. So higher the difference between these observed and expected, and larger will be your chi-square value. So again, we are interested in understanding the difference between the observed and expected count. So like how do we calculate? We calculate there's a difference observed minus expected. So observed minus expected, observed is 80 and expected is 88. That's why it is -8. So I mean, don't see the sign. Sign only tells you whether observed is more or observed is less. If the sign is negative, that means observed is less. If the sign is positive, that means observed is more. But since in the chi-square we square it, because in the numerator, if you see we square this value, that's why it doesn't matter whether it is less or more. But the bigger the difference of these observed and expected, the more is the chi-square value. So now, what is the hypothesis? So the hypothesis is like there is no relationship between these two variables, the null hypothesis. And the alternative hypothesis says that yes, there is relationship between the two variable. That's why we want this null hypothesis. We fail to accept the null hypothesis whenever there is a significant result. And we accept the alternate hypothesis when there is a like p-value is less than 0.05. So this again repeating the same thing, concept of expected frequency in a cell. So expected frequency is defined as the count in each cell if null hypothesis is true. That means there is no association. That means both the variables are independent of each other. And that is our expected count. Now there is something known as the this effect size. Effect size, how do we calculate the effect size in chi-square test? So there is effect size in chi-square test is calculated by phi and Kramer V. So if you see this phi and Kramer V, or you can remember the Kramer V. So if that is also, you get it in the software. When you click on that phi and Kramer V, you get that here we have written Kramer V, but many times you will see they write phi and Kramer V, because phi is for 2 by 2 table and Kramer V is like for n by n table. That means for 3 by 3, 4 by 4 or 5 by 5. But for 2 by 2 table, the value of phi and Kramer V are same. So how do you see that whether the effect size is small, medium or large? So if the effect size is like 0.1 to 0.3, you call it as a small. If it starts from 0.3 to 0.5, you call it as a medium. If it is 0.5 or more than 0.5, you call it large. So this is how you calculate, but you click this option only when the chi-square value is significant. If the chi-square value is less than 3.84, 3.84 is the chi-square value if the p-value is exactly at 0.05. So if the value of chi-square is less than 3.84, then you don't click this phi and Kramer V, because if there is no association, there is no point seeing whether this association it is of a small effect size or a medium effect size or a large effect size. So this is the chi-square test of association. So to summarize once again, chi-square test of association is, or also known as the chi-square test of independence, is performed with n by n table or 2 by 2 table. There are few assumptions which needs to be fulfilled. So the assumptions are like, first assumption is there should be two categorical variable and both the categorical variables should have two or more than two levels. There should be independence of observation. That means if you have counted one individual once, you are not going to count the same individual next time. And the observation should not be related to each other. And the fourth assumption is it should have a relatively large sample size, so that in each cell, at least expected cell frequency in each cell should be one or more than one. It should not be zero. And the at least 80% of the cell, the expected frequency should be more than 5. So these are few assumptions you should see, and then only you can go for a chi-square test of association. So we'll see the question, and we will also see so we'll perform this on the sixth data set only that we have used. So let's see what is the question. So we have to see the relationship between the gender and anxiety status, association between the gender and dietary preferences. So with gender, we have to see like anxiety, dietary, hypertension. So I will open this JAMOVI. Let me first open. So this is the older version. So let me close this. Why? Because I want you guys to see the newer one, which we have installed. So I will open this 2.6.26. Let me close these files. You can check the version. So it is the correct version. I will close these because too many JAMOVI, it got opened. And now after I open this, now I will open this file. Why? Because otherwise there are two versions in my PC. So if I don't open this newer version first and then open the dataset, the older version that is of 28, that will open. So this was the version which we have installed yesterday, version 2.6.26. So now I have to perform the chi-square test of association. So what is the option? So you have to go to this frequency. Yesterday we used this option of exploration. So now you have to see this option of frequency. So click this frequency. In frequency, you will see there are many options. If there is a one sample proportion test, we will discuss this also. But right now we are discussing this contingency table. And this contingency table, there is something known as the independent samples. Remember that independence of observation. With that, it is also known as the independent samples or chi-square test of independence, or it is also known as the chi-square test of association. And the other one is a paired sample. So if the values are related with each other, that means it is a paired value or a paired sample. We'll discuss that also. Then the choice of test is the McNemer test. Okay, so right now we are seeing this one. I'm demonstrating this contingency table for independent sample, that is chi-square test of association. So click that. Now see the question. With gender, I have to see anxiety, dietary preference, hypertension. And so let's see gender and anxiety status. So this is my gender. Now now here comes the what variable you will put in row, because if you see here, there is a row and there is a column. And if you see the nature of variable also, JAMOVI gives the hint. It is an icon of a sign of nominal variable, and this is the sign of ordinal variable. Simply, this is also the sign of nominal variable, and this is the sign of ordinal variable. So you can enter the nominal and ordinal variable, that is the categorical variable in these two, row and column. Now there is something known as row and there is something known as column. So which variable you will enter in row and which variable you will enter in column, and that will tell you whether you have to go with the column percentage and you have to go with the row percentage. Okay, because many times like participants also ask, like, what percentage should we report? Should we report the row percentage or the column percentage? So the rule is, you label one variable as a dependent variable and another variable as an independent variable. That means I want to see the anxiety in gender. Okay. So which will be my independent variable? Gender is my independent variable and anxiety is my dependent variable. So I'll move gender to the column. So remember, DC matlab means dependent variable will go to the column and independent variable will go to the row. So if gender is my independent variable, it will go to row. And then my dependent variable is the anxiety status. So this is the anxiety category. So anxiety category will go to this column. Okay. And now you can see there is a 2 by 2 table. And even if you have not applied any statistics, by default, if you see, it takes the chi-square test. So wait for some time. So now this is, you can see here, this, if you just describe the data. So if you see like no anxiety, there are 51 female having no anxiety and 12 female having anxiety. That means out of 63, 12 female, they are having anxiety, and in male out of 107, 20 male are having anxiety. Okay. Now coming to your expected versus observed count. So this is what in the 2 by 2 table, what you are seeing, this is what. Just please type in the chat box. Is this observed count or is this the expected count? Yes? Please type in the chat box. Yes, Dr. Subhapriya is right and Dr. Farzana is right. Observed count. Dr. Manisha is also right. Now, if I ask you to calculate the expected count for, let's say, for females. So if you see, if first calculate this, if you don't consider this gender distribution and consider only this. So out of 170, 32, like if you don't consider gender, just see the total number. Out of 170, 32 are having your anxiety. Okay. So calculate the percentage. So you have to calculate first, you calculate out of total what is this percentage. So 32 is what percentage of 170? Yes. I will also calculate. And I will apply the same percentage. So I will calculate 32 divided by 170. So this is your 18.8%. So that means if I don't consider this gender, there are 63. So out of 63, if I put like 18.8%, let me again do it. So out of 63 female, 18.8%. So I will multiply this with 0.188. So my expected count in this cell, yes, will be 18.8. Oh, yes, you all are right. So that's how you calculate the expected count. But observed count is like 12. So there is a difference. So there is a on the option of cell. By default, it's the observed count. If you see here, by default, it is observed count. But if you click on this expected count, this tells you the expected count. So I have clicked this expected count. So now you can see this is the expected and this is the expected. Again, this is expected, 86, and this is expected. So if you see the difference, what is the difference between observed and expected? Like 51 and 51.14. 12 and 20 and 20.14. So the difference is very less. That's why the overall chi-square value, if you see, it is very less. And that's why the p-value is, 0.954, which is like not significant at all. Because if you see, there's no difference. And again, if you have to show this table, we have to show this table, and if the chi-square is not significant, then we don't go for this 5 and Kramer V. You can see here, this is the effect size which we use. So this 5 and Kramer V, I'm not going to click this. Why? Because this doesn't add, this value is not significant. That's why I'll not click this. So for to give it in table, this is the row percentage. And like if you move your dependent variable in column, then you always have to click this row percentage. Row percentage means 19% of the women are having this anxiety and 19% of men are having anxiety. That means there is no association between the anxiety and the gender. That means they are independent of each other. So that's how we interpret the chi-square test. Now let's see some other variable. So if I see the other variable, it is the gender and dietary preferences and gender and hypertension grade. Okay. What is the question Dr. Subhapriya is asking? Which okay. The expected is calculated from percentage of total value. Is it so? Yes, Dr. Subhapriya. From total, why? Because even if you don't consider gender, out of total number, what is the like percentage of this anxiety? And then coming to this, in the result, this thing, there is a, this three icon is there, the three dot. If you click on that three dot, you can see, you can change the format, but it automatically, it comes like 2 or 3 decimal. You are asking? Okay. Yes, are there any other question? Farzana is saying we can say there is not much difference in prevalence. So we are, see, it is not a prevalence, we are seeing the association. Remember the term association. Now we are, it is not something like we are trying to tell the prevalence. We are just saying that is there any association between gender or and this anxiety or not? Okay. So that's why we can say that yes, gender is not associate. Like we cannot say like male gender anxiety is more common in female or more common in male. There is no association between gender and anxiety. That's what we can say right now.
And ma'am, my further question is like if this is insignificant result, then the association is not that much strong statistically, is it?
Oh, there is no association at all.
Okay.
Here, you cannot even say statistically strong. You say when the p value is like 0.06, or you can see some difference. But here, if you see the proportion, the percent, it is 19% in female and 19% in male. So
That
it
is
is equal. So that's why you say it's near to 1, this p value. And the
okay.
value of chi-square is 0. So you will say there is no association. You cannot say like association is not significant. That you say only when there is a some value of chi-square. But here the chi-square value is 0. That means there is no association. It is almost equal distributed in both male and female, irrespective of gender.
Got, ma'am.
It is like the same table, the first one. In the PPT, can you recall? Let me show you that slide where you people commented. Can you recall this slide?
Yeah, ma'am. Yeah,
The
ma'am.
first one, where
Yeah.
you people commented that there is no association. So this is almost same, right? There is some difference of point. Like you can see here, like 50, if you see the expected count, then it is not the same, but 51.14, 11.8, something like that. Otherwise, there is no difference. Okay.
Okay, ma'am. Got it, ma'am.
Okay. Any other question before? Okay. So I'll show with some more variable like gender and dietary preferences. So if you see,
Ma'am, one more doubt.
yes, Dr. Radha,
In this output, the chi-square value is 0.00.
let me again move that variable back because I have shifted that.
Okay.
So I will move this anxiety. Yeah. Now you tell me.
Ma'am, this chi-square value is 0.000.
Yeah.
So in many of the studies, we have seen the chi-square value 0.00 means it is significant like that.
No, it is
Association.
no. I think you are getting confused between this value
And
and
p-value.
so if p value is 0.00, then only chi-square can be. Okay.
Okay.
Chi-square, the value of chi-square should be at least 3.84. Remember, 3.84 to say that p-value is like 0.05 in 2 by 2 table. This is, I am talking of 2 by 2 table.
Okay.
Okay. So if you have seen somewhere that I think probably you are talking of this p-value.
P-value. Okay. Got it, ma'am.
Okay. Any
Thank
other? Oh, my pleasure. Any other query? Okay. If not, I will show you another way. We may try with some other variable. Let's say dietary preferences. So this is the dietary preferences, where dietary preferences has got three layers. I mean 3 levels. Other. Okay, so other is 1. Let me go to the data.
By mistake.
The dietary preferences.
यहाँ से नहीं हटेगा, डाटा में नहीं
Just a sec.
तो लिखना पड़ेगा, स्क्रॉल करके
2, where should I find?
उधर आ जाएगा, उधर लिखा है।
Yeah, this one.
ऊपर
So I'm just putting it to, so now it is having 2 levels. So if you see what is 1 and what is 2, oh, it is again there. That had that. Okay. So now you can see there are two. One is if you wish to see what was 1 and what was 2, so you can go to variable and you can click on this dietary preferences. I will just double click this and put this edit, and you can see, okay, we have not defined what is 1 and what is 2. So let's define this. So 1 is vegetarian. So I'm writing veg, because then if you don't label this, you will have problem when you are seeing the result. Non-veg. Oh, sorry. The moment you label this, now you can see. So I will go first. Let me, in this cell, I am not showing you the percentages first. So this is the 2x2 contingency table. Again, you can see here that the value of chi-square is 0.02. It is very less. And that's why the p-value is not significant. And if p-value is not significant, we are not going to click the phi and Kramer V. So let's see some other variable. BMI and what was the other question? Gender and hypertension grade. So I will go to this. Gender is already there. Instead of dietary preferences, I will put hypertension grade.
Ma'am, to getting the contingency table, where we have to click it, ma'am, after analysis?
Frequency.
Oh, okay.
This
Frequency, then to
independent sample chi-square test of.
okay. Okay. Thank you.
So this is your observed count. And in this case, you can see the value of chi-square is 19.6. At a p-value, it is significant. So how to interpret this? Now, for that, you need to see the table. So if you see the hypertensive or pre-hypertensive, so out of 63, for interpretation, you will be needing your, now check the assumption, whether we can go for chi-square or not. That I think in the previous one also I missed regarding there to observe constants. In this case, it is 170. So you have got enough sample size, but I will click the expected count. And this is a 3x2 table. So what is the total number of cell in a 3x2 table? Yes, please type in the chat box. You've already done it. I think 6. So yes, all cells should have at least 1 count. So in this case, if you see, just see all the cell. So all cell, these are the, and we don't have to see the observed. We have to see the expected. So all cell is having expected count more than 1. These numbers are more than 1. So this assumption is met, and all expected should be 80% should be more than 5. So since all are more than 5, so this assumption is met. In methodology, I assume, because I have collected this from all of you and I assume that you are not related to each other. So, and I have counted one individual only once. So that means my independence of observation, that assumption is met. And the nature of the categorical variable, both the variables are categorical. So that assumption is also met. So now I can go for interpretation of this chi-square test. So for interpretation, I'll be needing the percentage. So I'll click on this row-wise percentage and uncheck this expected count. So you click this expected count only to see the assumption. And after that, you uncheck that. Why? Because in result, we never put that expected count. We only show the, observed count. So here, if you see the percentage, let's say if I want to talk about the hypertensive. So there are only 6% of female who were hypertensive, whereas 25% of male were hypertensive. So yes, there is an association between the gender and hypertension. So that's the, and if it is significant, then I'll go for the phi and Kramer V. So I'll click on this phi and Kramer V, which is the effect size, and it tells you the Kramer V value. Phi is only when it is 2 by 2 table. Otherwise, it will give the value of Kramer V. So value of Kramer V is 0.34. That means there is a moderate, effect size, because moderate is from 0.3 to 0.5. 0.1 to 0.3, it is mild. 0.3 to 0.5, it is moderate. And 0.5 and more than that, it is strong. Large effect size. So this is the effect size. Have you understood up till this point? Then I have to introduce one concept again. Like after you have understood, once you have understood all these points. Have you understood the expected? Have you understood the percentage? Okay.
Ma'am, I have a query.
Yes, Dr. Subhapriya.
Ma'am, in this case, we have 3 subcategories for hypertension. So how will be the null hypothesis? How do you frame null hypothesis? Suppose like
Null
this
hypothesis.
hypertensive is okay, but suppose we have another subcategories where they are not like pre-hypertensive and hypertensive. Means like they are separate subcategories. How do you frame the
Can you give me the example of that category? Then it will be easy for me to frame a sentence. Otherwise, you can only say that there is no association between these two variables. That's the only null hypothesis which we make in case of chi-square. Because whatever your variable are, definitely your variables must be a categorical one. Then only you can go for a chi-square test. So the null hypothesis will say that there is no association. Whatever is the level of variable, level means whether it is a binomial variable or a binary variable or it is a polytomous variable. Binary means having 2 category. Polytomous means more than 2 category.
Okay. So we are seeing the association between the category total. Okay, ma'am, got it. Yeah.
Association is the categorical variable.
Okay.
I think Dr. Lokesh has asked, like if the question, if it doesn't have a 0 cell, a 0 count is there, then what to do? So there are various ways to tackle that. First, if in any cell, if the count is 0 and if it is a 2 by 2, then what you can do? You can go for a Fisher exact test. So but I was not coming to that, but since you have asked, I am replying. Because after this, okay, since you have asked, I'll explain this first. So in a 2 by 2 table, or you go for this Fisher exact test. Otherwise, if it is an n by n table, you go for a chi-square continuity correction, which is also known as the Yates correction. Traditionally, if you remember, previously we used to call it as Yates correction. But if there is any cell count, if it is 0, then you apply these values. Fisher exact test in 2 by 2 table and Yates correction, or the continuity correction if it is, then you report that chi-square value. Okay, that's the solution if any cell count is having this thing as 0. And again, Dr. Pradeep is also saying, and Dr. Geeta is also saying regarding phi and Kramer V. So see, there are 2 terms here. There is something known as the phi and something known as the Kramer V. So this phi is for 2 by 2 table. This value will only come in 2 by 2 table. In 2 by 2 table, the value of this phi and Kramer V is same. But this Kramer V, this is a effect size. Now for that, you need to understand what is effect size. So basically, effect size is something like if you want to compare two result, or if you want to compare like two, I have just calculated this association and probably I have another association. And if I want to compare two associations, then effect size is a standardized way to calculate or to measure the two, because p value doesn't tell you exactly. P value is dependent on sample size. You can also we have, I think, one session on a separate session on this effect size in meta-analysis also, because in meta-analysis this effect size is a very important concept. But to generally understand, to make you understand now, what do we in a literal term, what do we mean by effect size? So this only tells, if you see the chi-square value. So if chi-square value is significant, if p value is, let's say, less than 0.001, you only say that yes, there is there is a association between these two. But if you want to say what is the strength of association, means is the association very strong or moderate or low, it is significant. But if it is significant, that doesn't tell you regarding the strength of association. It only tells yes, there is an association and there is a significant association. That means statistically it is significant. But what is the strength of association? For that, you need to give the value of this effect size. And that's why you will see that these days, even when we will tell you the independent sample t-test, paired sample t-test, there also even if the p-value is significant, you always report the cohen d. We will tell you what is a cohen d, that is the effect size. So effect size is a measure which tells regarding the strength of association. Statistical significance is something different, which is measured by the p-value. But the strength of association is measured by this effect size. And this strength of association, in case of a categorical variable, is statistically it is communicated by the phi and Kramer V. So in this case, the value of Kramer V, but you click this value only when the value of chi-square is significant. Because if it is statistically significant, then only you comment on the strength. If it is statistically not significant, then you cannot comment on the strength. Did you get it, Dr. Geeta and Dr. Pradeep?
Yes, ma'am. Thank you, ma'am.
Okay. And Dr. Farzana is asking, I want to confirm my understanding related to interpretation. There's a strong association between the gender and hypertension grade, and it is statistically strong. Statistically strong word we never use. We write statistically significant. Like strong, for saying something strong, you need effect size. Like correlation. You can say the value, because correlation is also effect size. So if it is 0.8 or 0.5, p-value can be significant even if the value of I hope you know what is a correlation coefficient, Dr. Farzana.
Yes, ma'am. Now I recall, now I get clarification between these two terms. यानी मैं कंफ्यूज थी एंड वो बैक ऑफ माइंड ऐसे ही यूज कर लिया था, बट नाउ आई रिकॉल द एग्जैक्ट टर्म शुड व्हाट शुड आई यूज, इट्स सिग्निफिकेंट और नॉट सिग्निफिकेंट, नॉट स्ट्रॉन्ग और वीक.
स्ट्रेंथ, जो स्ट्रॉन्ग वर्ड यूज कर रहे हो आप, स्ट्रॉन्ग और नॉट स्ट्रॉन्ग, वो आपका इफेक्ट साइज बताता है. And significant, not significant, ये p value है. So दो चीजें हैं. That's why you will see these days we report, and in meta-analysis we don't give value to p value. P value we don't consider. If you see all the meta-analysis, we talk only about the effect size. Why? Because if you increase the sample size, if you take many people, p value is always significant. You keep on increasing the sample size, you will get the statistical significance, but you may not get the strength of association or the effect size that much strong. So effect size is the strength. And it is only tells you whether it is significant, or only statistical thing is more into this p value. P is more statistics term, and this strength is more of a clinician or more of a researcher, this thing.
My second question is about the Kramer's V. Kramer's V and Cohen's D is the same thing, or there is a different?
No. Don't go into the formula of these. In each statistical tests, there is a different formula to calculate effect size. Kramer V is the effect size for categorical. Cohen D is the effect size. There is a Hedges G, and there is so many type. There is a pseudo R square. Like in regression, you go, then that's a separate effect size. If you go to the ANOVA, it is the what was that known as effect size in an ANOVA. ANOVA is again, we call it as a something partial. Yes, partial and pseudo. So in every this thing, let me see if you go and see the ANOVA right now. So I think we will tackle this at an appropriate place. But currently, if you ask in every statistical test, there is a way to calculate effect size, and the
Okay.
formula is different. So you cannot say
But
that Kramer V and Hedges G or Cohen's D same. No, they are not, because T calculation formula is different. Chi-square formula is different. So this is also different. But again, and the interpretation is also different. The value keeps on changing. Here you are saying something at 0.3 as significant. I mean, moderate strong, so moderate association. So if you see the correlation coefficient, there you say moderate when it is more than like 0.4 or something like that. So values keeps on changing. They have got a separate table to say like which effect size is like mild or moderate or it is strong. But it is not same. Yes. Same in what sense? Both are effect size. In that sense, they are same. But the
okay, but
calculation
for
for
categorical, we should report the Kramers.
yes, yes. I mean, that's the only this is the way we have defined, and that's why in this interface, you cannot find a Cohen. Can you see a Cohen here in the categorical? You cannot see. You will see that in independent sample t-test. You cannot see a Cohen here. Okay.
Further, my question regarding the Kramers V, like when we should report the Kramers V, generally we are not reporting, right?
That
Just I have reported in only one of my manuscript, and it was between the independent variable only. वहां पे मैं वो देखना चाहती थी कौन कौन से इंडिपेंडेंट वेरिएबल के बिटवीन रिलेशंस है या हाउ दे आर इम्पैक्टिंग ऑन ईच अदर.
like I did not understand your question. Like you are saying that when you should report. That's what you're
Yes, yeah.
whenever like I again repeat, if the value of chi-square is significant, see, whenever this p value is significant, you should report this.
But is there any case like when we report the Kramers we using two independent variable? Here we are using the dependent and independent variable between.
That is only nomenclature because I wanted to make it clear, because again you will ask this question whether you should calculate row percentage or you should calculate column percentage. You may ask this question.
एक्चुअली मैम यानी मैंने एक मैन्युस्क्रिप्ट में यूज किया था एंड इट वाज गाइडेड बाय माय मेंटर कि हम लोगों ने हीट मैप बनाया था वहां पे बिटवीन द इंडिपेंडेंट वेरिएबल जो जो हमारे स्टडी में थे बिटवीन दैट इंडिपेंडेंट वेरिएबल क्या क्या रिलेशंस है वो देखने के लिए हम लोगों ने ये क्रेमर्स वी को रिपोर्ट किया था.
And if you can show me or send me that screenshot and this thing, probably I'll be able to comment more, because I am not able to understand and visualize the nature of your independent variable, how it came, the result and all. So probably I'll be able to guide you more. If you can send the screenshot of your that table or probably that particular paper which you are citing, it will be more useful for me.
Sure, ma'am. I'll send during this break. So
Okay, okay. Then
after
I
that,
may
we
show
can
it. I
discuss.
may show it here only, and then we can.
Okay. Sure, ma'am. Sure. Okay, thank you, ma'am.
Okay, Dr. Subhapriya. We are using English language. I mean, in between, I told few times Hindi, I'll speak English. I'm sorry for that. And any other question before? No. I've not told them another concept, which they digress to some other this thing. Another concept, one concept is left. That is your post hoc test. Now again, you will say that you have not used. Maybe many times we don't use, but we are just telling you how to do it in a complete way. There you will find many people who just report the chi-square and it's significant. They don't go for Kramer V. and they don't report this standardized or adjusted residual. But again, that's the standard way of doing it. So now if the chi-square value is significant, so do you know what is a post hoc test? Yes. Can you please type in the chat box? Any rough idea what is a post hoc test? Can I see the chat box? So Dr. Farzana is saying no. Okay. Anyone else? Dr. Subhapriya is saying no. Okay. Dr. Pradeep is also saying no. And I'm thinking, should I introduce this concept now? Yes, I may. I will. We will talk about this post hoc term post hoc separately, but right now I'll explain what this post hoc is. Okay. So initially, okay, thank you. I'm assuming others also to be no, but what this post hoc is something like now that there is a there is a significant relationship. Okay. This post hoc we'll talk more in ANOVA. So now there are, if you see, there are 8 cells. Okay. How many? There are 6 cells. How many cells are here? 3/2 table. There are 6 cells. Now, if you want to know that which are the cells which are responsible for this significant p-value, means which is the cell where the difference between observed and expected is maximum, which is responsible, because if the difference between observed, remember I have used the term residual to show the difference between observed and expected. I have just used that term once when I was taking the session. But again, there is something known as the residual. Do you know what is a residual? Munisha is writing. Do you know what is a residual? So residual is like you are expecting, suppose you are expecting that in a particular month you will like or like let's say, okay, let's say with a monthly expenditure. I'm just giving you example because I have not, like we have not prepared slide for this residual and post hoc for chi-square. So let's assume like you all have a rough estimate of your monthly expenditure. Do you have a rough estimate of your monthly expenditure? Let's say on fuel. What is the rough monthly expenditure on fuel? So let's say, can you please, few of you write your on this chat box your monthly expenditure on your travel or fuel or petrol or diesel, whatever you use. Yes, can you please write? So like Farzana is writing 5,000, Subhapriya 3,000, Rahul is writing 1,500. Okay, 3,000 Lokesh. So suppose for all of you, whatever, like 10,000. Okay, Vedapriya is writing 10,000, 4,000. In any month, that's a roughly monthly. In any month, that is your expected. In any month, because of any reason, your actual expenditure is either less or more than your expected one. Because expected is your usual, whatever you have seen probably in the last 12 months. In any month, if it exceeds or less, maybe you are mostly on, you did not go because of some reason, then it is less. Or maybe you went more, we all get conveyance allowance also. So you have visited more. And then you say that the expected, the observed is more or less than the expected. So the difference between this observed and expected is known as the residual. So now have you understood what is this residual? So this difference between observed and expected is known as residual. Now in each cell, you have seen earlier also, larger the difference between observed and expected, greater is the value of chi-square, isn't it? Because in the formula of chi-square also, the observed and expected is in the numerator. So larger the difference between the observed and expected, the larger will be the value of chi-square. Can I say like that? Please type in the chat box yes or no. At least. So Farzana is asking, writing yes, Radha yes, Subhapriya yes. Okay. Now, I want to know like which of these cells are responsible for giving this significant chi-square value. This we can understand by post hoc test. Means after we get a significant result, now I have to comment which cell is having like this difference, the largest, because of which my overall chi-square is significant and my effect size is good. For that, I go for this post hoc test. So if you click there is something known as the unstandardized residual. Unstandardized means it is the raw, means it gives you the difference between observed and expected. So I'll click this unstandardized residual and I will uncheck this and I'll click this expected count also. So now if you have to see the difference, can you see the value observed and expected? What is the value difference between observed and expected here in this cell, the first cell? Yes. You all calculate. 34 minus 21.86. Please type in the chat box. What is the difference between, let's take the example of, so 12. Okay, roughly it is 12 point something. If you see the same thing here, what is the value? Can you see it is 12? 12.14, 12.14. This is the unstandardized, means the difference between observed and expected. And male also it is the same value but with a negative sign. Because here also if you see 25 minus 37 minus 25, it will be the same. Okay, so here also you will see it is the same. So this is the unstandardized residual, means difference between observed and expected. Now we use these standardized residual and adjusted residual wherever, because you standardize this, you divide this with the standard deviation and standard error and you standardize this residual. So you should click this standardized residual, and wherever the value of the standardized residual is more than 2, then it is this particular cell is responsible for shifting your chi-square. So in this case, you can see that there are 4 cells having a standardized this thing. These 2, rather than this, you can say that these 2 cells means like in normotensive and hypertensive. In pre-hypertensive, it was not. But in normotensive and hypertensive group, the standardized residual was more than 2. And these 2 cells, the same will be with for male also, but it will be with the negative sign as opposite to the female. If the female is minus, then it will be plus. So you can say that this cell, the normotensive and gender and the hypertensive and gender, the standardized residual in these two, in all these 4 cells was greater than 2, and this is responsible for like shifting the chi-square or having this chi-square value a significant value. So this is known as the post hoc test. Yes, Dr. Lokesh. It simply you are right. It will help you in understanding like which association. So it is basically the association between this normotensive and gender and hypertensive and gender, means the distribution is in these 2 category is significantly different. The difference was not much in the pre-hypertensive. So this also helps you to write the result and discussion, because it goes one step beyond your simply, like if you say it's simply significant, then your reader will not be able to understand. If you give this table and simply say that it was significant, then I'll have to go and check each cell. Again, if I say that yes, it was my strength of association or my phi or Kramer V was moderate. Okay, there was a moderate association. But again, if I want to know like in which category, then I may say that, in normotensive and in hypertensive, it was like this association, it was more profound and it has this influence. This has influenced most the chi-square value. So basically, that's how you interpret your post hoc test. So initially, in the earlier version, this post hoc test was not there. Whereas if you go see in the SPSS, it was there since beginning. So when we used to take the workshop on SPSS, then we used to tell this post hoc test. But when we shifted to JAMOVI, we did not, like if you see our earlier videos, we have not covered this post hoc test because this option was not there in JAMOVI. But this time with this version like 2.6.26, they have added this. So my earlier version, that is 28, which I opened initially, it is not having that post hoc. So yesterday when Dr. Ravi was asking like, should he uninstall the earlier version and install this? So I asked him to go with that earlier also. But if like he wants to perform this post hoc test in chi-square, then he won't be available. It won't be available. This option is not available. Okay. So that's why we say that this JAMOVI is like every time it is no upgrading itself. Like people, they are adding new module, adding new options. So that's why even we also, if we see after some time, we see that yes, interface got changed. Like there's addition of few more things in every time whenever we open this JAMOVI. So have you understood up till this point? Farzana is asking how should we select? So can you see here it's written here, highlight, we take the value above 2.
Look criteria.
Yes, ma'am.
Generally, yeah, you tell what are you saying?
Just how can we decide that we should put it 2, or is there any rule
It
for
is
that?
not we
Or
are deciding. It is not we are deciding. I will give you the reference paper on the basis of which, like, it has been decided that it should be more than 2. Okay, we are
okay,
not the deciding one.
okay.
It's the leading people. I am forgetting that name of the person.
Who is doing it's the right who is
Okay, who has based on which even the JAMOVI or even the SPSS, they have decided that this standardized residual, if the value is more than 2, many times they say depending on the number of table. So many people, they take 3 also. But if you go by that author, if it is more than 2, we say that yes, it is like this cell is influencing the p value the most, the chi-square value. Okay, so if it is okay, then we may go to the breakout room.